I was told by a VU ham friend that in order to experiment with loaded coil dipole antennas, it is essential to have an LCR meter. It was during the discussion on my recently homebrewed loaded coil 80 meter antenna which would not resonate on 80 meter. The coil which I had wound myself probably did not have the needed inductance due to wider spacing of winding than in the design. This is the new LCR meter which arrived today after an online purchase a few days back. This digital inductance capacitance resistance meter, that is LCR meter, came with a couple of red and black test leads with crocodile clips, a calibration certificate, instruction leaflets, and a 9-volt battery. There was a nice carrying pouch with zip fastener as well. Everything came packed in a cardboard carton which I have just removed. First, I went through the calibration certificate and instruction leaflets quickly before proceeding further. Now I have removed the polythene cover of the LCR meter and the 9-volt battery, as well as attached the test leads on the corresponding input terminals. You can see that the test leads are quite short, unlike the multimeter, possibly to reduce stray capacitance and inductance. Now I have removed the test leads and kept the LCR meter inverted to see the rear side and removed the screw from the battery cover using a star-edged screwdriver. The connectors for the 9-volt battery can be seen inside the battery compartment. Battery has been connected to the connector and the battery inserted inside the battery compartment, and it is fitting well inside it. Now the LCR meter has been kept back in the correct position and the power switched on by a long press of the power button. LCD display has been lit up and shows 1, which is the default out of range display. Measuring range of this LCR meter is 200 picofarad to 2000 microfarad for capacitance, 200 microhenry to 20 henry for inductance, and 200 ohms to 2 mega ohms for resistance. There is also an option for checking the forward voltage drop of a diode. There are few safety precautions to be borne in mind. Do not give any alternating or direct current voltage to the input terminals. While measuring capacitance, make sure that the capacitor has been fully discharged prior to testing. While changing switching function, test leads should be removed from the test points. Make sure that the correct function has been selected prior to testing. Here I have attached a 1000 microfarad electrolytic capacitor after discharging it to the test leads. I had also tried inserting it into the slots which also showed same value, but there was loose contact and fluctuation of value when the pressure on the capacitor was changed. Testing using test leads may introduce some stray capacitance. Short leads have to be used for lower values of capacitors to reduce errors. If 1 is displayed as the reading, the next higher range should be selected. If zeros are seen, then the next lower level has to be selected. There is provision for zero correction using the rotary knob. If 0 is seen for all ranges, the capacitor is probably open circuit. If the reading is unstable, it may indicate a leaky capacitor. A 470 microfarad capacitor is being tested here and the value is seen as 446. This test and the previous tests were done in the 2000 microfarad range of the selector switch. Now a 470 picofarad capacitor is being tested in the 20 nanofarad range. It is shown as 0.49. 0 suggests that this is not the correct range for testing. 471J written on the capacitor indicates the capacitance and tolerance. J indicates 5% tolerance, meaning that actual value may be within 5% above or below the nominal value. This testing is done in the 200 nanofarad range, and we see two zeros, meaning the range is much above the needed one. Now the testing is being done in the 200 picofarad range, and it shows 1, indicating that the value is beyond the measurable range for the selection. All these are not the recommended methods to test. This test is in the 2 nanofarad range, and the value is shown as 0.479 without any preceding zeros. That means this is the correct selection for testing the value of this capacitor. Now a 1 kilo ohm resistor is being tested in 2 kilo ohm range, and the value shown is 995, which is within the 5% tolerance limit. This is a demo of shorting the test leads for a short period before measuring values below 200 ohms to find the resistance of the leads. Shorting for long periods can drain the battery and may cause internal damage to the LCR meter and should be avoided. Resistance of the test leads should be subtracted from the measured value of low value resistors. 330 ohms resistor being tested in the 2 kilo ohms range of the selector switch. Here is a 5.6 ohm resistor being tested in the 200 ohms range. Though a 0 is shown before the measured value of 4.8, I have no option in this LCR meter to reduce the range below 200 ohms for higher accuracy. Maybe I have to use another meter with higher resolution at lower range. Planning to do the diode measurement and coil inductance measurements on another day.